Hello, in this lecture we will find out the length of line segment MN. In the drawing we have square ABCD. We know that one side of square ABCD is equal to 12 units. That is to say AB equals to BC equals to CD equals to DA equals to 12 units. Inside this square we have a circle and a semicircle, and the circle is tangent to the square at 2 points, and it is also tangent to diagonal AC at this point, and the semicircle is tangent to the square at this point, and it is also tangent to diagonal AC at this point, and it touches side DC at this point. And we want to find out the distance between the centers of the circle and the semicircle. The center of the circle is at point M, and the center of the semicircle is at point N. And we want to find out the length of MN, or the distance between the centers of the circle and the semicircle. So, in the first step, we will define the point of tendency of tangent AB with this circle as point P, and we will define the point of tendency of tangent BC with this circle as point Q. We will also define the point of tendency of tangent AC with this circle as point R. We will define the point of tangency of tangent AC with the semicircle as point S. And finally we will define the point where the semicircle touches a side DC as point T. And we will define the length of line segment PB as A. So actually, according to our definition, PB equals to A, and what is the value of the length of line segment AP? From the drawing you can see that AP is equal to AB minus PB. That is to say AP equals to AB, that is 12 units, minus PB, that is A according to our definition. So in conclusion, we found out that AP equals to 12 minus A. You can write here that AP equals to 12 minus A units. In the next step, I will present to you a new rule. That's actually rule number 1. According to rule number 1, the lengths of two tangents from a common external point. To a circle are equal. So I will read rule number 1 again. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and we have the external point, point P. Point P is an external point in relation to this circle because point P is not located inside this circle nor on this circle, but is located outside of this circle. Therefore, point P is defined as an external point in relation to this circle. So, if from the external point, point P, we will draw two tangents to this circle, then the first tangent will be this tangent. We will define the point of tangency of the first tangent with this circle as point A. Then we will draw the second tangent to this circle. And we will define the point of tangency of the second tangent with this circle as point B. And according to rule number 1, the lengths of two tangents, that is to say, the length of the first tangent is PA, and the length of the second tangent is PB. And according to rule number 1, the length of two tangents from a common external point, that is to say from point P, that is considered, that is defined as a common external point. So the length of two tangents from a common external point to a circle are equal. That is to say, the length of the first tangent is PA, the length of the second tangent is PB, and according to rule number 1, those two lengths are equal to each other, that is to say PA is equal to PB. So whenever you have two tangents from a common external point to a circle, like in this drawing, then the lengths of those two tangents will be equal to each other. In this case, PA will be equal to PB. Okay, so we actually can implement rule number 1 in our drawing, because at point P, point B is defined as an external point, and in relation to this circle, and from point B, the external point B, we have two tangents to this circle. The first tangent is tangent BP, and the second tangent is tangent BQ. And according to rule number 1, they are equal to each other. That is to say, BP is equal to BQ. But according to our definition, BP is equal to A. So from this equation, A equals to BP equals to BQ, we will derive that BQ is also equals to A. So we can write here that BQ equals to A. And what is the value of the length of QC? The length of QC, as you can see it from the drawing, that QC is equal to BC minus BQ. Again, BC minus BQ equals to QC. So QC will be equal to BC, that is 12 units, minus BQ, that is A. In conclusion, we found out that QC is equal to 12 minus A. Okay. We will focus on the external point A. From the external point A, we have two tangents to this circle. The first tangent is tangent AP, and the second tangent is tangent AR. And according to rule number 1, they are equal to each other. That is to say, AP is equal to AR. But according to what we have already found out, AP equals to 12 minus A. AP is equal to 12 minus A. According to what we have already found out. So from this equation, 12 minus A equals to AP equals to AR, we will derive that AR is also equals to 12 minus A. We can write here that AR equals to 12 minus A. We will continue to focus on the external point A. From the external point A, we have two tangents to the semicircle. The first tangent is tangent AS, and the second tangent to the semicircle is tangent AD. And according to rule number 1, they are equal to each other. That is to say, AS is equal to AD according to rule number 1. Again, AD equals to AS according to rule number 1. But according to what is given us in the question, AD equals to 12 units. So we can write here that AD equals to 12 units. And from this equation, 12 equals to AD equals to AS, we will derive that AS is also equals to 12 units. Okay, so here we can write down that AS is equal to 12 units. And what is the value of RS, line segment RS? It is very easy to see from the drawing that RS is equal to AS minus AR. Again, AS minus AR equals to RS. So RS equals to AS, that is 12, minus AR, that is 12 minus R. So RS equals to 12, we'll open the brackets here, minus 12, minus and minus is plus, so it is here. 12 minus 12 is 0, and minus and minus is plus, so it is plus A. So in conclusion, we found out that RS is equal to A. Okay, RS equals to A. You can write here that RS equals to A. In the next step, we will focus on the external point, point C. From the external point, point C, we have two tangents to this circle. The first tangent is tangent CQ, and the second tangent from point C is CR. And according to rule number 1, they are equal to each other. That is to say, CQ is equal to CR according to rule number 1. But we have already found out that CQ equals to 12 minus A. So we can write here that CQ equals to 12 minus A. And from this equation, 12 minus A equals to CQ equals to CR, we will derive that CR is also equals to 12 minus A. CR equals to 12 minus A. So we can write here that CR is equal to 12 minus A. And what is the value of SC? The value of line segment SC. It is very easy to see from the drawing that SC is equal to RC minus RS. Okay, SC equals to RC minus RS. That is to say, SC is equal to RC or CR, that is 12 minus A, minus RS, that is A. So we found out that SC equals to 12 minus A minus A. That is to say, SC equals to 12 minus 2A. Here we can write down that SC equals to 12 minus 2A. In the next step, I will present to you a new rule. This is actually rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. I'll read rule number 2 again. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and the center of this circle is at point O, and we also have tangent AB to this circle, tangent AB is tangent to this circle at this point. We define the point of tendency of tangent AB with this circle as point M. I write it down that point M is the point of tendency of tangent AB with this circle. We will join points O and M together by a straight line. OM is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point O, and ends at point M, that is the point of this circle itself. Therefore, OM is the radius of this circle, so we will define it as R. So here we have the radius OM that is drawn to the point of tendency, that is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AB will be perpendicular to the radius MO. Again, AB is perpendicular to MO. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Again, a tangent to a circle, that is to say AB, is perpendicular to the radius drawn to its point of tendency. The radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, the tangent AB will be perpendicular to the radius MO. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? So we actually can implement rule number 2 in our drawing. Here we will join points M and P together by a straight line. MP or PM is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point M, and ends at point P, that is the point on this circle itself. Therefore, PM is the radius of this circle, and the radius PM or the radius MP, it is drawn to the point of tendency, that is to say it is drawn to point P, that is the point of tendency of tangent AB with this circle. Therefore, whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. That is to say, in this case, the tangent AB will be perpendicular to the radius PM. So the radius AB perpendicular to PM, that is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. According to rule number 2, we also know that all the angles inside the square are right angles, therefore angle ABC will be a right angle, that is to say it will be equal to 90 degrees. In the next step we will join points M and Q together by a straight line. So here, line segment MQ is the radius of this circle because of the fact that it starts from the center of the circle and ends at point Q, that is the point of the circle itself. Therefore, MQ is the radius of this circle. We have the radius MQ, it is drawn to the point of tendency, that is to say it is drawn to point Q, that is a point of tendency of tangent BC with this circle. Therefore, whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent BC will be perpendicular to the radius QM. So BC perpendicular to QM, that is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So in quadrilateral PBMQ, we have 1, 2, 3 right angles, and the sum of 3 right angles is 270 degrees. So 270 degrees plus the size of the fourth angle, that is actually angle PMQ. In total, the sum of those 4 angles must be equal to 360 degrees. I repeat again, the sum of 3 right angles is 270 degrees plus the size of the fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation and we get that angle PMQ, the missing angle, is equal to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle PMQ is a right angle, it equals to 90 degrees. So here, angle PMQ is a right angle. So actually in quadrilateral PBMQ, we have 4 right angles, and I'll present to you rule number 3. Actually, any quadrilateral that has 4 right angles is at least a rectangle. Okay, so we will relate to quadrilateral PBMQ as a rectangle. And according to rule number 3, the opposite sides of a rectangle are equal to each other. number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. So, in rectangle PB and Q, the opposite sides are equal to each other. That is to say, PM equals to MQ, or PB equals to MQ, PB equals to MQ according to rule number 3. But PB is equal to A according to our definition. So from this equation, A equals to PB equals to MQ, we will derive that MQ is also equals to A. MQ equals to A. So here MQ equals to A. So MQ, that is the radius of this circle, is equal to A units. Likewise, according to rule number 3, BQ also must be equal to PM. BQ equals to PM according to rule number 3. But we have already found out that BQ equals to A, and from this equation A equals to BQ equals to PM, we will derive that PM is also equal to A. PM equals to A. So we actually found out that quadrilateral PBMQ is not a rectangle but a square. Why? Because all of its sides are equal to each other and they are equal to A. Okay? So what is the value of diagonal AC? The value of the length of diagonal AC, you can see it from the drawing, that the diagonal AC is equal to AR plus RC. I will repeat again. The length of diagonal AC, from the drawing you can see that it is equal to AR plus RC. AR plus RC equals to the length of diagonal AC. So AC, diagonal AC, the length of diagonal AC, it is equal to AR, that is actually equals to 12 minus A, plus RC, RC is also equals to 12 minus A. So in conclusion, we found out that the length of diagonal AC is equal to 12 plus 12 is 24, and minus A and minus A is minus 2A. So in conclusion, the length of diagonal AC is equal to 24 minus 2A. In the next step, we will focus on the right triangle ABC. We will implement the Pythagoras theorem on the right triangle ABC. Triangle ABC by PT, the letters PT are abbreviation for Pythagoras theorem. According to Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is AC, so the square of the hypotenuse is AC squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AB squared plus BC squared. Again, according to Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. We have already found out that AC equals to 24 minus 2A, so we can substitute AC by 24 minus 2A, and AC squared will be equal to 24 minus 2A squared. That equals to AB squared. AB equals to 12 units. It is given us the question. So AB squared will be equal to 12 squared plus BC squared. BC is also equal to 12 units. So BC squared will be equal to 12 squared. Also, so in conclusion, we found out that according to equation number 1, 24 minus 2A equals to 12 squared plus 12 squared. So 24 minus 2A squared equals to 12 squared plus 12 squared. 12 squared plus 12 squared is 2 times 12 squared. Here we take a root out of this equation, equation number 1, and we get that according to equation number 1, the square root of 24 minus 2A is actually equals to the square root of 2 times the square root of 12 squared. The square root of 12 squared is 12. Why? Because the root cancels the square and we left only with 12. So in conclusion, we found out that according to equation number 1, 24 minus 2A equals to square root of 2 times 12. Here we will add to this equation 2A and we will subtract square root of 2 minus 12 and we will get that according to equation number 1, 2A is equal to 24 minus square root of 2 times 12. We will divide equation number 1 by 2 and we will get that according to equation number 1, A equals to 24 over 2 is 12 minus 12 over 2 is minus 12 over 2 is minus 6. So in conclusion, we found out that A, that's actually the radius of the circle, equals to 12 minus 6 times square root of 2. Okay? In the next step, we will define the radius of the semicircle as B. Dn is the radius of the semicircle. Why? Because line segment Dn starts from the center of the semicircle, that is to say from point N, and ends at point D, that is a point on the semicircle itself. Therefore, Dn is the radius of the semicircle, that is to say it equals to B according to our definition. Likewise, NT is also the radius of the semicircle. Why? Because line segment NT starts from the center of the semicircle, that is to say from point N, and ends at point T, that is a point on the semicircle itself. Therefore, NT is the radius of the semicircle, that is to say it equals to B units. And what is the value of line segment TC? Here, from the drawing, it is very easy to see that the length of line segment TC it will be equal to DC minus dN minus NT. Okay, I repeat again. The length of line segment TC equals to DC minus dN minus NT. So actually TC equals to DC, and DC is 12 units. This equals to 12 units minus dN, that is B, minus NT, that is also B, the radius of the semicircle. So in conclusion, we found out that TC equals to 12 minus B is minus 2B. So TC equals to 12 minus 2B. So we can write here that TC equals to 12 minus 2B. In the next step, we will join together points N and S by a straight line. Line segment NS is the radius of the semicircle. Why? Because line segment NS starts from the center of the semicircle, that is to say from point N, and ends at point S, that is a point on the semicircle itself. Therefore NS is the radius of the semicircle, that is to say it equals to B units. So here the radius NS, it is drawn to the point of tangency, that is to say it is drawn to point S, that is the point of tangency of tangent AC with this semicircle, and whenever you have a radius that is drawn to the point of tangency, then the tangent will be perpendicular to the radius. In this case, the tangent AC will be perpendicular to the radius NS. Okay? That is to say, AC perpendicular to SN, that is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. And because of the fact that angle NSC is a right angle, then triangle NSC is a right triangle. The green triangle NSC is a right triangle, so we can implement the Pythagoras theorem on the right green triangle NSC. So according to, but first of all we will find out the value of the hypotenuse NC. What is the value of the hypotenuse NC? NC, it is actually equals to NT plus TC. That is to say, NC equals to NT, that is B, plus TC, that is 12 minus 2B. So in conclusion, we found out that NC is equal to 12 and B minus 2B is minus B. In conclusion, we found out that NC equals to 12 minus B. Now we will implement the Pythagoras theorem on the right green triangle NSC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is NC, so the square of the hypotenuse is NC squared. and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to ns squared plus sc squared. So I repeat again, in the right grand triangle NSC or NCS, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, nc squared equals to ns squared plus sc squared. So, and we have already found out that nc is equal to 12 minus b, so nc squared will be equal to 12 minus b squared, and it equals to ns squared. Ns equals to b, so ns squared will be equal to b squared plus sc squared. Sc equals to 12 minus 2a, so sc squared will be equal to 12 minus 2a squared. So here we found out that 12 minus b squared equals to b squared plus 12 minus 2a squared. We'll find out the value of the expression 12 minus 2a. The value of 12 minus 2a will be equal to 12 minus 2 times a, but we have already found out that a is equal to 12 minus 6 times square root of 2. So actually, here we have 12 minus 2 times 12 is minus 24. Minus 2 times minus 6 is plus 12. 12 times square root of 2. So here we have 12 times square root of 2, and 12 minus 24 is minus 12. So in conclusion, we found out that 12 minus 2a, it is actually equals to 12 times square root of 2 minus 12. So here we can substitute 12 minus 2a in equation number 2 here by 12 times square root of 2 minus 12, because they are equal to each other. We'll do it now and we will get that according to equation number 2, (12 minus b squared is 12 squared plus b squared minus 2 times 12 times b, that equals to b squared plus 12 minus 2a, and we substitute 12 minus 2a by 12 times square root of 2 minus 12, all squared. Here we have b squared on both sides of equation number 2, so b squared will get cancelled, and what is left from equation number 2 after we cancel b squared, what is left is actually here from on this side of the equation we have 12 squared minus 2 minus 12 is minus 24, so we have minus 24b, that equals to, here we will take 12 as a common factor out of this expression, and what is left from 12 times square root of 2 after we took from it 12 as a common factor, what is left, it is actually square root of 2. And what is left from minus 12 after we took from it 12 as a common factor, what is left, it is actually minus 1, all squared. So we got that according to equation number 2, 12 squared minus 24b is equal to Here we have all inside the expression inside the brackets here is in power of 2. So here we have 12 square times square root of 2 minus 1 square, according to the rule that if you have x times y on the power of m is equal to x to the power of m times y to the power of m. Okay, according to this algebraic identity, we get that 12 times square root of 2 minus 1 squared, it equals to 12 squared times square root of 2 minus 1 squared. So according to equation number 2, 12 squared minus 24b equals to 12 squared. So here we have square root of 2 minus 1 square. Square root of 2 minus 1 square equals to square root of 2 square, that is 2, plus 1 square, that is 1, minus 2 times square root of 2 times 1. So according to equation number 2, I found out that 12 squared minus 24b equals to 2 times 12 square. We'll open the brackets. It will be 2 times 12 square plus 1 times 12 square minus 2 times square root of 2 times 12 square. So here we have 12 square on both sides of the equation, so 12 square will get cancelled. What is left from equation number 2 after we cancel 12 square? What is left? It is actually in this side of the equation. What is left is minus 24b, that equals to 12 square is 144, and 144 times 2 is 288. Minus 12 square is 144, and 144 times minus 2 is minus 288, multiplied by square root of 2. Here we'll divide the equation number 2 by 24, and we'll get that according to equation number 2, minus b equals to 288 over 24 is 12, minus 288 over 24 is minus 12, times square root of 2. Here we will multiply equation number 2 by minus 1, and we'll get that according to equation number 2, b equals to 12 times square root of 2 minus 12. So I found out the value of b, that is actually the radius of the semicircle. It equals to 12 times square root of 2 minus 12 units. And we have already found out that the value of a, it is actually equals to 12 minus 6 times square root of 2 units. And what will be the value of a plus b? The value of a plus b will be equal to, here we have minus 12 plus 12 is 0, and 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. So in conclusion, we found out that a plus b equals to 6 times square root of 2 units. So here, in the next step, we will join points M and R together by a straight line. Line segment MR is the radius of this circle because of the fact that line segment MR starts from the center of this circle and ends at point R, that is a point on this circle itself. Therefore, MR is the radius of this circle, that is to say it equals to A units. So here, the radius MR, it is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle, and whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AC will be perpendicular to the radius Rm. So AC is perpendicular to Rm, that is to say this angle is equal to 90 degrees and this angle will be also equal to 90 degrees. According to rule number 2. In the next step, from point M, we will draw perpendicular on Rm. So actually, this angle will be equal to 90 degrees according to our construction. And we will extend the radius NS by a straight line until it intersects with the perpendicular from point M. We will define the intersection point between the extended NS and the perpendicular from point M as point X. So actually we created here quadrilateral RMXS. And here we have NS is the radius of the semicircle that equals to B units. NS as a radius, it must be a straight line. And when we extended the radius NS by a straight line, we got line segment NX. So when you extend a straight line by a straight line, the result will be still a straight line. So we got NX by extending the straight line NS by straight line, we got segment line NX, that it is still must be a straight line because of the fact that when you extend a straight line by straight line, it still must be a straight line. So NX is a straight line. I'll write it down. Line segment NX is a straight line. I'll repeat again, when you extend a straight line by straight line, the result will be a straight line. Therefore, NX must be a straight line. And we have rule number 4. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. The sum of the angles on one side of a straight line is equal to 180 degrees. I repeat on rule number 4 again. The sum of the angles on one side of a straight line is equal to 180 degrees. So we have the straight line NX. If we focus on the upper side of the straight line NX at point S, then according to rule number 4, the sum of the angles here at point S must be equal to 180 degrees. Which angles we have in the upper side of the straight line NX at point S? We have here 90 degrees. And we also have angle RSX. In total, the sum of those two angles must be equal to 180 degrees according to rule number 4. I repeat again, according to rule number 4, 90 degrees, the sum of the angles of the upper side of the straight line NX at point S must be equal to 180 degrees. That is to say, 90 degrees plus the size of angle RSX. In total, they must be equal to 180 degrees. We will subtract 90 degrees from this equation, and we get that the value of angle RSX is equal to 180 degrees minus 90 degrees is 90 degrees. So angle RSX is a right angle, it equals to 90 degrees. This angle is a right angle. So actually in quadrilateral RMSX we have 1, 2, 3 right angles, and the sum of 3 right angles is 270 degrees. 270 degrees plus the size of the fourth angle, that is actually angle MXS. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we'll subtract 270 degrees from this equation, and we will get that angle MXS, the missing angle, is equal to 360 degrees minus 270 degrees, that is 90 degrees. So we found out that angle MXS is a right angle, it equals to 90 degrees. Therefore, quadrilateral RMSX has 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle. So we can write down that quadrilateral RMSX is at least a rectangle. If not a square, it is at least a rectangle, because it has 4 right angles. And according to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, in rectangle RMSX, RM must be equal to SX. RM must be equal to Sx according to rule number 3. But Rm is equal to A. It is the radius of the circle. So I can write down that Rm equals to A, and from this equation A equals to Rm equals to Sx, we will derive that Sx is also equals to A. We can write here that Sx equals to A. Likewise, Mx must be equal to Rs according to rule number 3. Mx equals to Rs according to rule number 3. Again, Mx equals to Rs. But according to what we have already found out, we found out that Rs equals to A. And from this equation, Mx equals to Rx equals to A, we will derive that Mx is also equals to A. Mx equals to A. You can write here that Mx is equal to A. So actually, in rectangle, in triangle MXN, angle MXN is a right angle, therefore triangle MXN is a right triangle. So we will implement the Pythagoras theorem on the right orange triangle, triangle MXN. Okay? So we will implement the Pythagoras theorem on the right orange triangle, triangle MXN. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is mn, so the square of the hypotenuse is mn squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to mx squared plus xn squared. I will repeat again. In the right orange triangle MXN, according to the Pythagoras theorem, mn squared equals to mx squared plus xn squared. So here mn is the missing variable, so we leave it as it is, and it equals to mx squared. Mx equals to a, so mx squared is a squared plus nx squared. Nx equals to a plus b, so xn squared will be equal to a plus b squared. And it equals to mx squared. So we found out that according to equation number 3 in Pythagoras theorem, a squared plus a plus b squared equals to mn squared. It is actually equals to mn squared. This is the square of the hypotenuse. Mn squared. Again, a squared plus a plus b squared equals to the square of the hypotenuse. That is actually mn squared. We have already found out that a equals to 12 minus 6 times square root of 2. So we substitute a by 12 minus 6 times square root of 2 all squared. And a plus b, we already found out that a plus b equals to 6 times square root of 2 squared, and it equals to mn squared, the missing variable. So here we will open the brackets on this side of the equation number 3, and we will get that according to equation number 3, 12 minus 6 times square root of 2 squared is 12 squared, plus 6 times square root of 2 squared is 6 squared is 36. Square root of 2 squared is 2, and 36 times 2 is 72. And we just tried to find out that 6 times square root of 2 squared is 72. And we also have to subtract minus 2 times AB, that is minus 2 times 12 times 6 times square root of 2, and it is equal to mn squared, the square of the hypotenuse. So according to equation number 3, we actually found out that (72) plus 72 is 144. 12 squared is 144. 144 plus 144 is 2 times 144. Minus 2 times 6 is 12. 12 times 12 is 144. So here we will have minus 144 times square root of 2. That equals to mn squared. So actually found out that according to equation number 3, 2 times 144 minus 144 times square root of 2 equals to mn squared. Here we will take 144 as a common factor out of those two expressions, and we will get that here 144 is a common factor, so what is left from 2 times 144 after we took from it 144 is a common factor, what is left is actually 2. And what is left for minus 144 times square root of 2 after we took from it 144 is a common factor, what is left it is actually minus square root of 2 that equals to mn squared. Here we take a root out of this equation, equation number 3, and we will get that according to equation number 3, mn, the missing line segment, is equal to square root of 144 is 12, and we also have to put inside the square 2 minus square root of 2. Okay, so the answer to the question is that the distance between the centers of the circle and the semicircle is equal to either 12 times square of 2 minus square root of 2 units, or in terms of numbers is equal to 9.18 units. Okay. I'll repeat again. The answer to the question is that the distance between the centers of the semicircle and the center of the circle is equal to either 12 times square of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. In the next step, I will summarize the lecture. Actually, we wanted to find out the distance between the centers of the semicircle and the circle. The center of the semicircle is at point N, and the center of this circle is at point M. The circle and the semicircle are located inside this square ABCD. One side of square ABCD is equal to 12 units. And we want to find out the length of line segment MN. So first of all, we defined the point of tendency of tangent AB with this circle as point P. We defined the point of tendency of tangent BC with this circle as point Q. We define the point of tendency of tangent AC with this circle as point R, and we define the point of tendency of tangent AC with this semicircle as point S, and we defined the touching point of the semicircle with side DC as point T. Then we defined line segment PB as A, and if line segment PB equals to A, then AP will be equal to AB minus PB, that is to say AP will be equal to AB, that is 12, minus PB, that is A. So in conclusion, we found out that AP equals to 12 minus A. Then I presented to you a new rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and we have the external point P of this circle, and from the external point P we draw two tangents to this circle. The first tangent is tangent PA, the point of tendency of the first tangent with this circle is at point A, and the second tangent is tangent PB, the point of tendency of the second tangent with this circle is at point B. Then according to rule number 1, the lengths of those two tangents are equal to each other. So the PA is equal to PB. So whenever you draw two tangents to a circle from a common external point of that circle, like in this drawing, we do two tangents from the common external point P to that circle, then the lengths of those two tangents will be equal to each other. In this case, PA will be equal to PB. Okay? So here we can implement rule number 1 in our drawing, because we have here the external point B. From the external point B, we have two tangents to this circle. The first tangent is tangent BB, and the second tangent is tangent BQ. And according to rule number 1, they are equal to each other. That is to say, BP equals to BQ. But according to our definition, BP equals to A. And from this equation, A equals to BP equals to BQ, we will derive that BQ is also equals to A. So we can write here that BQ is equal to A. Then, so here, what is the value of QC? QC equals to BC minus BQ. Okay, QC equals to BC minus BQ, that is to say, QC equals to BC, that is 12 units, minus BQ, that is A. So, in conclusion, we found out that QC equals to 12 minus A. Here, QC equals to 12 minus A. Then we focused on point A, the external point A. From the external point A, we have two tangents to this circle. The first tangent is tangent AB, and the second tangent to this circle is tangent AR. And according to rule number 1, the lengths of those two tangents will be equal to each other. That is to say, AP is equal to AR. AP equals to AR according to rule number 1. But we have already found out that AP equals to 12 minus A. So from this equation, 12 minus A equals to AP equals to AR. We will derive that AR is also equals to 12 minus A. So we can write here that AR equals to 12 minus A. Then we continue to focus on the external point A. From the external point A, we have two tangents to the semicircle. The first tangent is tangent AD, and the second tangent is tangent AS. And according to rule number 1, they are equal to each other. That is to say, AS is equal to AD. So AD equals to AS, but we know that AD equals to 12 units because it is one side of square ABCD. Therefore, it equals to 12 units. From this equation, 12 equals to AD equals to AS. We will conclude that AS is also equals to 12 units. So we can write here that AS is equal to 12 units. Okay? Then, what is the value of RS? It is very easy to see from the drawing that RS it equals to AS minus AR. Again, RS equals to AS minus AR. So AS equals to 12 units. AR equals to 12 minus A. So RS equals to 12 minus A. We open the brackets and we got that RS equals to 12 minus 12 is 0. Minus and minus is plus. So in conclusion, we found out that RS equals to A. Line segment RS equals to A units in its length. Then we focused on the external point C. From the external point C, we have two tangents to this circle. The first tangent is tangent CQ. The second tangent is tangent CR. And according to rule number 1, they are equal to each other. Okay, according to rule number 1, CQ equals to CR. But we have already found out that CQ equals to 2F minus A. So from this equation, 2F minus A equals to CQ equals to CR. We will derive that CR is also equals to 2F minus A. So we can write here that CR equals to 2F minus A. Then we calculated the length of line segment SC. You can see it from the drawing that it is very easy to see that SC is equals to RC minus RS. Again, RC minus RS equals to SC. Okay, again. Here. So here we found out that according to rule number 1, CQ equals to CR and CQ equals to 2F minus A. Therefore, from this equation we concluded that CR is also equals to 2F minus A, and we found out that SC equals to RC minus RS. Again, SC equals to RC minus RS. So SC equals to RC, that is 2F minus A, minus RS, that is A. We opened the brackets and we found out that SC equals to 12 minus A minus A, and 12 minus A minus A is 12 minus 2A. So in conclusion, we found out that SC equals to 12 minus 2A. Then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and the center of this circle is at point O, and we have also tangent AB, tangent AB is tangent to this circle is point M. Point M is the point of tendency of tangent AB with this circle. Here OM is the radius of this circle, and the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency. Then whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AB will be perpendicular to the radius MO. Again, AB is perpendicular to MO. That is to say this angle equals to 90 degrees, and this angle is also equals to 90 degrees. Okay, whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius. In this case, AB is perpendicular to MO, that is to say this angle equals to 90 degrees, and this angle is also equals to 90 degrees. We implemented rule number 2 in our drawing. Here we join points M and P together by a straight line. MP is the radius of this circle. So we have the radius of this circle that is drawn to the point of tendency, that is to say it is drawn to point P, that is the point of tendency of tangent AB with this circle. So whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AB will be perpendicular to the radius PM. So AB is perpendicular to PM, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. And we have, we know that all the angles inside a square are right angles, therefore angle ABC will be equal to 90 degrees. We join points M and Q together by a straight line. MQ is the radius of this circle, and we have here the radius MQ, it is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent BC with this circle, and whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent BC will be perpendicular to the radius QM. So BC is perpendicular to QM, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. So in quadrilateral PBMQ we have 3 right angles, 1, 2, 3, and the sum of 3 right angles is 270 degrees, so 270 degrees plus the size of angle PMQ in total, they must be equal to 360 degrees. 270 degrees plus the size of angle PMQ in total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation and we got that angle PMQ, the missing angle, is equal to 360 degrees minus 270 degrees. That is to say it equals to 90 degrees. So this angle equals to 90 degrees. So quadrilateral PBMQ that has 4 right angles, it must be at least a rectangle. And we have rule number 4, rule number 3 that says that the opposite sides of a rectangle are equal to each other. So here the opposite sides of rectangle PB and MQ are equal to each other, that is to say PB is equal to MQ. PB equals to MQ according to rule number 3. But PB equals to A according to our definition. So from this equation A equals to PB equals to MQ, we will derive that QM is also equals to A. So QM equals to A, that is to say the radius of this circle is equal to A. Likewise, BQ must be equal to PM according to rule number 3. But we have already found out that BQ equals to A. So from this equation A equals to BQ equals to PM, we will derive that PM is also equals to A. PM equals to A, so we actually found out that quadrilateral PBMQ is not a rectangle but a square because of the fact that all of its sides are equal to each other, they are equal to A. And what is the length of diagonal AC? The length of diagonal AC is AR plus RC. Again, AC equals to AR plus RC. We have already found out that AR equals to 12 minus A, and RC is also equals to 12 minus A. So in conclusion, we found out that AC equals to 12 plus 12, that is 24. Minus A plus minus A is minus 2A, so in conclusion, we found out that AC equals to 24 minus 2A. Then we implemented the Pythagoras theorem on the right triangle, triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, AC squared equals to AB squared plus BC squared. AC is 24 minus 2A, so we substitute AC by 24 minus 2A squared, that equals to AB squared, AB squared, AB is 12, so AB squared is 12 squared, plus BC squared. BC is also 12, so BC squared is also 12 squared. So in conclusion, we found out that according to equation number 1, 24 minus 2A squared equals to 12 squared plus 12 squared. 12 squared plus 12 squared is 2 times 12 squared. We took a root out of this equation, equation number 1, and we found out that according to equation number 1, 24 minus 2A equals to the square root of 2 times square root of 12 square, and the square root of 12 square is 12 because of the fact that the root cancels the square and we left only with 12. So in conclusion, we found out that according to equation number 1, 24 minus 2A equals to the square root of 2 times 12. Here we added 2A to this equation and we subtracted square root of 2 times 12. And we found out that according to equation number 1, 2A equals to 24 minus square root of 2 times 12. We divided equation number 1 by 2 and we got that A is equal to 24 over 2 is 12 and minus 12 over 2 is minus 6. So in conclusion, we found out that A, that is the radius of the circle, is equal to 12 minus 6 times square root of 2 units. Then we defined the radius of the semicircle as B, that is to say the end, that is the radius of the semicircle is B, and t, that is also the radius of the semicircle, is equal to b. And what is the value of line segment TC? It is very easy to see from the drawing that the value of line segment TC will be equal to DC minus dn minus nt. Okay, here TC equals to DC minus dn minus nt. DC equals to 12 and dn equals to b, and t is also equals to b. It is the radius of the semicircle. So in conclusion, we found out that TC equals to 12 minus b. That is to say, TC equals to 12 minus 2b. TC equals to 12 minus 2b. So we found out that TC equals to 12 minus 2b. Then we found out the value of the hypotenuse NC. The hypotenuse NC, actually, here we join points N and S together by a straight line, and S is the radius of the semicircle, that is to say it equals to B, and we have here the radius NS, it is drawn to the point of tendency, that is to say it is drawn to point S, that is the point of tendency of tangent AC with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AC will be perpendicular to the radius SN. So AC is perpendicular to SN, that is to say this angle equals to 90 degrees, and this angle is also equal to 90 degrees. So we actually found out that the green triangle SNC is a right triangle because of the fact that it has one angle that equals to 90 degrees. So we implemented the Pythagoras theorem on the right green triangle SNC. Okay? So what is the value of the hypotenuse NC? The hypotenuse NC, it is very easy to see that the hypotenuse NC equals to NT plus TC. The hypotenuse NC equals to NT plus TC. NT equals to B. This is the radius of the semicircle. Plus TC, that is 12 minus 2B. So here NC, the hypotenuse equals to 12. B minus 2B is minus B. So in conclusion, we found out that the length of the hypotenuse NC is 12 minus B. So now we can implement the Pythagoras theorem on the right green triangle SNC. In order to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, NC square equals to NS square plus SC square. NC equals to 12 minus B, so NC square will be equal to 12 minus B square. That equals to NS. NS is the radius of the semicircle, that is to say it equals to B. So NS square is B square plus SC. SC equals to 12 minus A, 12 minus 2A. So SC square will be equal to 12 minus 2A square. So here we calculated the value of 12 minus 2A. What is the value of 12 minus 2A? The value of 12 minus 2A is 12 minus 2 times A, and A is equal to 12 minus 6 times root of 2. So here we have 12, we open the brackets, here 2 times 12 is 24, and 2 times minus 60 minus 6 is minus 12. So in conclusion, we found out that 12 minus 2A equals to 12 minus 24. Actually here we have minus 2, minus and minus is plus, so it is minus 2 times minus 6 is plus 12. So it is here plus 12 times root of 2. 12 minus 24 is minus 12. So in conclusion, we have here 12 times root of 2 minus 12. So in conclusion, we found out that 12 minus 2A, it is equal to 12 times root of 2 minus 12. Okay, so we can substitute 12 minus A in equation number 2 here by 12 times square root of 2 minus 12. Why? Because they are equal to each other. We did it and we got that here. We open the brackets. 12 minus 2a is 12 square plus b square minus 2 times 12 times b. That equals to b square. And here we substituted 12 minus 2a by 12 times square of 2 minus 12 squared. Here we have b square on both sides of the equation, so b square will get cancelled. What is left on equation number 2 after we cancelled b square? What is left? It is actually 12 square minus 2 times 12 is minus 24, so here we have minus 24b. Here we took 12 as a common factor out of this expression, and we got the expression that 12. So inside the brackets, what is left from this expression? What is left? It is actually square root of 2. What is left from minus 12? After we took 12 from it as a common factor, what is left? It is actually minus 1. So in conclusion, this expression after we took from it 12 as a common factor equals to 12 times square root of 2 minus 1 all squared. Okay. So here we have 12 square minus 24b. That equals to 12 square times square root of 2 minus 1 square, according to the algebraic identity that x times y to the power of m equals to the x to the power of m times y to the power of m. According to this algebraic identity, we get that 12 times square root of 2 minus 1 all squared, it equals to 12 square times square root of 2 minus 1 square. Okay, so here we have 12 square minus 24b, that equals to 12 square. Here we calculated the value of square root of 2 minus 1 square. Square root of 2 minus 1 square equals to square root of 2 square, that is 2, plus 1 square, that is 1, minus 2 times square root of 2 times 1. Okay, so we got that 12 square minus 24b. Here we open the brackets. It is 2 times 12 square plus 1 times 12 square minus 2 times square root of 2 times 12 square. Here we have 12 square on both sides of the equation, so 12 square will get cancelled, and we left only with minus 24b, that equals to 12 square is 144, 144 times 2 is 288, minus, and 12 square is 144, 144 minus 2 is minus 288, times square root of 2. And here we divided equation number 2 by 24. Minus 24b over 24 is minus b. 288 over 24 is 12. Minus 288 over 24 is minus 12. So here we have minus 12 times square root of 2. And here we multiply the equation number 2 by minus 1, and we got that the value of b is equal to square root of 2 times 12. Minus 12, this is the radius of the semicircle, and we have already found out that a equals to 12 minus 6 times square root of 2 units. Then we calculated the value of a plus b. Here it is very easy to see that a plus b will be equal to minus 12 plus 12 is 0. And 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. So in conclusion, we found out that a plus b equals to 6 times square root of 2 units. Then we actually joined points M and R together by a straight line. MR is the radius of this circle because of the fact that it starts from the center of the circle and ends at point R, that is the point on this circle itself. Therefore, MR is the radius of this circle, that is to say it equals to A. In the next step, here from point M, we draw perpendicular on RM. So this angle equals 90 degrees. But here we have the radius MR that is drawn to point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC in this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. That is to say the tangent AC will be perpendicular to the radius RM. So AC is perpendicular to RM, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 2. In the next step, we did a construction from point M. We do perpendicular on RM, so this angle equals to 90 degrees. Okay? And we extended NS by a straight line until it intersects with the perpendicular from point M. And we define the intersection point of the extended NS and the perpendicular from point M as X. So we created quadrilateral RMXS. In this quadrilateral we have two right angles, and here NS is the radius of the semicircle that equals to B units. Therefore it is absolutely a straight line. NS is a straight line. We extended the straight line NS by a straight line, and when you extend a straight line by straight line, the result will be still a straight line. So the result NX is a straight line. Okay, we know that NX is a straight line, and we have rule number 4. According to rule number 4, the sum of the angles on one side of the straight line is equal to 180 degrees. So if we focus on the upper side of the straight line NX at point S, then the sum of the angles must be equal to 180 degrees. Which angles we have at point S? We have here 90 degrees plus the size of angle RSX. In total they must be equal to 180 degrees according to rule number 4. 90 degrees plus the size of angle RSX, in total they must be equal to 180 degrees according to rule number 4. We subtracted 90 degrees from this equation, and we got that the value of angle RSX equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that this angle is the right angle, is equals to 90 degrees. So actually in quadrilateral RMSX we have 3 right angles, and the sum of 3 right angles is 270 degrees. So 270 degrees plus the size of angle MXS, in total they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So we subtracted 270 degrees from this equation, and we got that the value of angle MXS is equal to 360 degrees minus 270 degrees. It is actually equals to 90 degrees. So we found out that this angle MXS is equal to 90 degrees. Therefore in quadrilateral RMSX we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle. So we will relate to quadrilateral RMSX as a rectangle. And we know that the opposite sides of a rectangle are equal to each other according to rule number 3. That is to say, the opposite sides of rectangle RMSX are equal to each other. That is to say, RM is equal to SX. RM equals to SX according to rule number 3. But we know that RM is equal to A. So from this equation A equals to RM equals to SX, we will derive that SX is also equals to A. SX equals to A. Likewise, according to rule number 3, in rectangle RMSX, RS must be equal to MX. RS must be equal to MX according to rule number 3. But we have already found out that RS equals to A. So from this equation MX equals to RX equals to A, we will derive that MX is also equals to A. So we found out here that MX is also equals to A, so we actually found out that quadrilateral RMSX is a square because of the fact that all of its sides are equal to each other, they're equal to A units. Then, because of the fact that angle MXN is equal to 90 degrees, then triangle MXN the orange triangle MXN is the right triangle. So we can implement the Pythagoras theorem on the right orange triangle MXN. According to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is mn, so the square of the hypotenuse is mn squared, and it must be equal to mx squared plus xn squared. mx equals to a. nx equals to a plus b. So mx is mx squared is a squared plus nx squared is a plus b squared. It must be equal to mn squared, the hypotenuse squared. So we know that a equals to 12 minus 6 times square root of 2, so 12 squared is 12 minus 6 times square root of 2 squared. A plus b equals to 6 times square root of 2, so a plus b squared will be equal to 6 times square root of 2 squared, and it equals to mn squared. We open the brackets here. 12 minus 6 times square root of 2 is 12 squared, plus 6 times square root of 2 squared is 6 squared is 36, times square root of 2 squared is 2, and 36 times 2 is 72. Minus 2 times 12 times 6 times square root of 2, and we have also 6 times square root of 2 squared, that is, we have already found out that is equal to 72. Here 12 squared is 144, 72 plus 72 is also 144, so 144 plus 144 is 2 times 144. So in conclusion, we found out that according to equation number 3, 2 times 144 minus, here we have 2 times 6 is 12, 12 times 12 is 144, so in conclusion this expression equals to minus 144 times square root of 2. So it is minus 144 times square root of 2, that equals to mn squared. Here we took 144 as a common factor out of those two expressions, and what is left from this expression after we took from it 144, what is left? It is actually 2. What is left of this expression after we took from it 144 as a common factor? What is left? It is actually minus square root of 2. Here we took a root out of this equation number 3, and we found out that mn, the line segment that we are looking for, that is also the distance between the centers of the semicircle and the circle, equals to the square root of 144. The square root of 144 is 12, and we also must put inside the root 2 minus square root of 2. So in conclusion, we found out that mn, the length of line segment mn, or the distance between the centers of the semicircle and the circle, is equal to either 12 times square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. I'll repeat again, the distance between the centers of the semicircle and the circle, that is to say the length of nm, is equal to either square root of 2 times square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. Okay, thank you very much.